Solar Group presents. This was once just a dream of the skies, the freedom of flight, of round-the-world journeys. Yet we've made it happen. But what did it take? Our dreams became our goals. Our concepts turned into our plans. Our ideas have transformed into a roadmap and production technology. And the years ahead are booked out with development and construction, components and materials, model manufacturing and testing. All this marks the progress from dream to result. Join us on this journey. Solar Group presents a new generation of airships. The best way to predict the future is to create it, so let's do so together.
Hello everyone, friends. You're back with the new Generation Airships project. We're live once again. As always, I'm Gennady Babanin, and with me is the Technical Director of AERONOVA, Fedor Konstantinov.
Yes, hello everyone, friends.
Yes, today we'll be talking about the news from January. I think we should start with the most interesting one.
And which one is that?
The aeroplane. How ours flew, how it performed during the tests. Everyone's really interested to find out. And when will those flights continue?
Yes, friends, once again, greetings to you all. It seems like today is our first time going live.
After the holidays.
Yes, after New Year's. Actually, first of all, I'd like to point out the fact that New Year's has passed. January is such a short month. And usually, everyone takes ages to get going, you know. There are loads of memes about it. About that, really? Yes, about that. That in January, no one feels like working. But this time, it just so happens that
We've been flying non-stop, really actively.
Yes, straight into work. In fact, no one even really had time to get out of the habit. And actually, we had this situation. You know, we were moving from the old office to this one. And we finally, you could say, moved in right before New Year's. We hadn't even managed to set up all the systems yet. For example, the office access system. And then, during the New Year holidays, staff were trying to get into the office. For several days in a row, without success. Because the lift in this building was switched off. You could go up the stairs, but then the pass wouldn't work on the door. So, what I'm saying is, no one even switched off from work. Yes, basically, that's why we came. In general, now everything is happening quite well, quickly, and in an organized manner. And what exactly is happening? Well, Gina asked about the aeroplane. Did you see the video? The aeroplane was flying. And it did so quite well, steadily, and many times. What can I say? It was a new experience. This is a completely different machine. It's not the Nova 01. Now, the Nova 01, there's a small degree of being overweight, but it's still there. And if you turn off all the engines, it starts to sink slowly. The aeroplane, on the other hand, has a high degree of being overweight. It's not going to sink slowly. It approaches the ground quite actively, let's put it that way. And with the Nova 01, for example, just to explain for those who aren't familiar, and to remind those who are, there are only two propellers, and they are mounted on a single pivoting beam and turn in sync. So, to take off in the Nova 01, for instance, we'd tilt the propellers to generate upward thrust, but at an angle. That's the most efficient direction for takeoff. You could give it a bit of throttle, so to speak, and then cut it. And it would hop up and then slowly fly like that. And with these, let's say, bursts of thrust, you could keep the Nova 01 in the air. Right? That sort of thing doesn't work with the aeroplane. It behaves almost like a quadcopter. For example, when all the propellers are turned vertically, it generates vertical thrust and takes off vertically. And if something goes wrong, well, naturally, it will fall quite quickly. I want to say, but actually, it will sink. And all of its, how should I put it, all the advantages of its aerodynamic shape only really come into play at speed. When it starts propulsive movement, that is, when it begins to fly forward, its body starts to work, providing aerodynamics, an additional lift appears. And because of this, it was actually quite scary to lift it off the ground at first, to stabilize it, and so on. But then, when you consider all the various details, even starting from the fact that, for example, if the Nova 01 has 2 propellers on a single tilting beam, the aeroplane already has 4 propellers arranged in a quadcopter layout, and each motor is free and can rotate independently of the others. But of course, they are dependent on the algorithms that we program into it. And even starting from the very mechanism for rotating these motors, there are all these fine adjustments. For example, let's say we turn motor X 15 degrees forward. Well, I showed 90, but let's say we turn it 90 degrees forward, and then we return it to its home position, but it still doesn't, well, it seems to have come back, but there's a slight play. And even this slight play was enough for the craft to behave unstably in the air. And all these little adjustments, when you turn the motors one way, you physically check, measure everything, and enter correction coefficients. For example, you release the rotation, the motor returns, and then you tweak it a bit more by the correction coefficient. And you do this in every direction, and all sorts of other things. Plus, the blades work differently, even though it says plus or minus that they're the same. That's absolutely not the case. So, once we had calibrated everything, as you saw in that video, it holds its altitude steadily, it turns beautifully right on the spot. It's like a tank turn, but here it's more of an aircraft turn, since it actually flies, unlike tanks that do not. AERONOVA 01 could not do that. The Nova 01 has a tail thruster, it's located at the back, so it can hover, but not as actively or as controllably as the aeroplane. The aeroplane can fly and practically turn on the spot. With the Nova 01, we never managed to do that even once. Plus, the aeroplane holds its altitude very steadily. With the Nova 01, that's difficult to do because your point of application, this vertical force, is in the middle, and if the body starts to wobble a bit, whether from the wind or something else, then, well, it's impossible. There's an axis here around which it wobbles and so on. Here, because everything is spread out, that's actually an advantage. Of course, it was scary.
Will that be possible on the next version of the Nova 01 if we have 4 propellers on the new models?
Yes, of course. The Nova 01, let me remind you, is essentially a copy of the Nova 2 airship. And as I said from the start, it's not the optimal small airship. And the aeroplane right now isn't the optimal airship either. The aeroplane is actually Dmitry Sergeyevich Khmel's very first project, and well, to be honest, it's going all right, but there are some issues. There's a lot that's new, a lot that's difficult, and a lot we didn't consider at the time. Dmitry Sergeyevich didn't think of it during its development. But over this year, we'll create the optimal one. Both the optimal small airship of the classic shape and the optimal hybrid airship. And, of course, the large one, the Nova 2. So this year, we need to get at least 3 aircraft in the air, maybe even more, because there are still. Well, maybe not this year, or maybe it will be this year. There are also orders from Dubai. But more on that later. Yes, most likely, the airship with the optimal classic shape won't use a twin propeller configuration. It will have 4, or maybe even 6 propellers.
Is that kind of concept being considered as well?
Yes, of course. In general, large airships, truly large ones, like the Nova 2, have 2 propellers, because that's the absolute minimum for a big, serious airship. As its volume increases, its power-to-weight ratio also grows, and that's the minimum power-to-weight ratio, so you can't really go wild with it. But on bigger airships, there are a lot of propellers and engines along the sides, and the more there are, the better, the more controllable, and so on. And on a small airship as well, it should be like that, 4, 6, 8, as you like. Yes, the question is the same. Are they different, freely rotating, independent or dependent? Those are all details. But yes, it will be the classic type.
With the same maneuverability. By the way, on the aeroplane, what was remarkable was that, probably, if it hadn't been for the snow on the airfield, it could have almost turned around on its own right inside the hangar and driven out.
No, hang on. It did turn around on its own in the hangar and drove out by itself, yes. Well, we did give it a bit of support.
Yes, where there was snow, we gave it a little push.
Yes, and the engine is so powerful, we nearly broke it at the moment when we were already taking off, but it was all fine, we landed it back safely. And Dima Orlov is our control system developer and also our operator. So he decided, well, to make a really cool turn. Basically, when he turns the propellers just a bit, gives it a bit of thrust, the aeroplane starts turning on the spot, whether it's on the ground or in the air. It doesn't matter. Only in the air, it compensates for the loss of vertical thrust a bit by adding some more. But that's not the point. We were turning carefully, but then on the ground he decided to make a sharp turn, and the aeroplane, I do not know, spun around by about 45 degrees in literally an instant. And this is a big thing, 20 meters long, almost 5 meters wide, and you can imagine, it spun 45 degrees around its axis in a second, just like that. It
Jerked. The frame barely held together. If it had been rigid, it would have broken. But because the engines, in this direction, are supported by the envelope, here, up and down, the frame holds them, but in this direction, they are supported by the envelope. The envelope flexed a bit, and the frame did not break, but it looked, well, we were pretty scared,
to be honest. So, it can taxi around the site on its own. It can enter and exit hangars by itself. But there is one, but it's actually a bit too small for such tricks. In calm weather, that's fine, but if there's even the slightest disturbance, a bit of wind, and at the moment when it's coming out of the hangar, all these turbulent, unpredictable air currents can start affecting it. It needs to be weighted down. That's why we developed this robotic trolley for moving it in and out of the hangar for Nova 01. We were planning to make it before the new year, but a lot of effort was spent on Dubai, so everything was postponed. Now, everything has already been designed and purchased, and soon assembly will begin. There really should be a robotic trolley that will take Nova 01 out. Basically, it can accompany the aeroplane, it can assist, it can tow it out, but most likely, everything will work together with many different factors involved. In short, it will add a lot of weight to it. The point is that, as escorts, when we were taking the aeroplane out, it was simply that we weighed something, and so that the wind wouldn't blow the little airship into the hangar, we gave it some mass. This robotic trolley will weigh enough. It will hold it in the right places, and it will be able to push it on its own quite easily, or it can pull it. Either way, it doesn't matter.
Will it be universal, with a universal mount, and will it fit any airship?
Well, for our small ones, yes, but again, this is just a prototype, simply for working out the processes. Basically, it's for testing the control system, so that, roughly speaking, you give the command to the control system to couple, they find each other, couple up, the algorithms work, the actuators work. Of course, the mechanical devices themselves will be different, depending on the future size and so on. So, small airships, yes, we'll make them the same for the small ones, say, for Nova 2 and that size. We'll make them identical, but between themselves they will be different. The carriages themselves will be different. The frames will be different. The payloads, the brains will be the same, yes. The algorithms will probably be the same, but for the larger ones, maybe you'll need 2, or maybe 3. We'll figure all that out as we go along.
Right, and about the aeroplane. So, based on the tests we've already carried out, what have we worked through? What are we planning to work through in the near future? And the main question, probably, is when do we plan to move on to the next stage?
Just to remind you, we're in the Moscow region, actually in Moscow, and we fly in the Moscow region. If you've been keeping an eye on the weather, you'll have seen that we've been absolutely buried in snow. So, the airfield has been covered in snow as well, and in general, there's been a lot of snowfall. We've flown in heavy snow before, of course, but that time there was both snow and calm weather, so we were lucky. So, as soon as the weather conditions allow, we'll carry on flying. What have we managed to practice so far? We can take off and land smoothly, we can move around the airfield, but we haven't yet transitioned to fast horizontal flight. That is, so far we have been flying more or less like a quadcopter. We have not engaged the dynamics of the hull. The hull dynamics will kick in at around 40 km per hour, when the airship starts moving forward and the hull begins to play a role. We have not reached that stage yet. There are a number of reasons for this, mainly safety protocols and the flight test program. So we've gone through everything, and all that's left is to move on to this full-fledged horizontal flight, and as soon as we get good weather and the airfield is cleared. You might ask, what? They don't clear it? Yes, they don't. That's how it is. They cleared it after New Year, but before New Year, well, once the New Year holidays were over, only then did they start clearing the runway, because this isn't Sheremetyevo, it's not Domodido, it's a small private airfield. Everyone was on holiday, and so on, and so on. And generally, if there aren't any requests for flights, and there's also a training center there, and if there are no classes at the training center, then no one clears anything. They cleared it for us. When we arrived, they cleared the area in front of the hangar for us.
Yes, at our request.
Well, naturally, yes. I'm getting there, of course.
Moreover, our hangar is right at the very end, as if, well, I don't know, whether on purpose or not, but for some reason, they never made it that far. So we had to go and ask for a tractor to come specifically to our hangar and clear it.
Because the area is huge, there's only one tractor, and it's all work, and that's fuel as well, when the tractor is clearing. And the gates to the airfield were always open. I asked why. Well, you always say they should be closed, but the tractor drivers were tired of opening and closing the gates all the time, and right next to us is a Gazprom petrol station, directly by the airfield. The tractor was just going back and forth to refuel. Well, in short, it all costs money, obviously. Anyway, we'll carry on flying as soon as the weather allows. We plan to fly both the Nova 01 and the aeroplane. With the aeroplane, it's about continuing flight tests, moving into full horizontal flight, and collecting data on the aerodynamics of the fuselage. As for the Nova 01, it's about continuing the work on full autonomy, integrating our external software with the internal software that's in the flight controllers and computers. So, Nova 01 is moving on to that stage. The aeroplane remains at the stage it's currently at. By the way, there have also been some massive changes in the software. Previously, the map was a top-down view, basically, like we're used to with Google Maps or any other map, it's flat. You see it from above, and something moves across the flat map, plus the altitude is shown in numbers. If anyone ever needed it, well, we needed it, and we saw it as numbers. Now, basically, I can't remember who exactly did it, you'd have to ask Milod, but now we have a 3D map. So, in our current software, when you open it, you see a 3-dimensional map, and you can see in 3D where each airship is and how it moves in space.
So, not 2D, but 3D, so to speak.
Yes, and it's become really convenient for the operators, for understanding, and for visualization, and this happened over the New Year holidays. Basically, the lads spent a whole year developing this software, and over the New Year holidays, they moved it onto a 3D map. Yes, so there you go, because no one was taking a break. I found that out as well. We come into the office, and Milord says, Fedor, come here. I want to show you something. Look, look, look.
He was showing off.
Yeah, look what we've done, and I'm like, well, cool. So now we need to connect all this up and continue testing it on Nova 01. So, flight testing, well, we're waiting for the weather.
Since we're not doing flight tests at the moment, what are we working on in the office right now?
This week? Yes. Well, actually, the company's priority is, of course, Nova 2. And everyone has always been working on it. It's just that the aeroplane, Nova 01, is what flies, what we can show, talk about, discuss, maybe crash Nova 01 and fix it, and so on. It's tangible here, while over there it's not tangible yet. But really, everyone is working on Nova 2, the main team and all the main processes are there. So, what's happening there?
Well, some parts can already be touched.
Well, yes, you saw the picture of the control surfaces, the fact that the tail control surfaces were being worked on. The technological process. Now they are already sending photos showing that the control surfaces have been painted and riveted. We haven't published them yet because, well, to paint them, you need to build a paint booth. And even though it sounds like a booth, it's actually a full-sized room. Basically, it was finished before the New Year holidays, and after the holidays, they just had to finish up a few small things. Now there's a paint booth. All the aluminium parts, of course, are painted according to special technological processes. Everything is done according to all the standards and so on. No improvisation. After all, this is aviation equipment, it's serious. And in the future, it will be certified. That's why everything isn't moving as quickly as we'd like. But it's progressing. Maybe I'll send you a photo of the painted control surfaces. You can have a look today. So, basically, the metal work is being done. The technological processes are being mastered. At first, we were just bending one set of angles, then another, then a third, and then more complex surfaces. Once we learned how to do all that, we started assembling things. During assembly, we realized that everything fits together. For example, you might have a set of 10 parts. Naturally, each part has its own tolerances. And when you assemble them, you need to check the overall tolerance. So, with the first control surface, we assembled it, checked it, and everything matched up. Excellent, wonderful. That means we can continue making such large parts, like the entire nacelle, for example. Even though we've already stamped out the parts for the caisson and so on. Because the total tolerance doesn't accumulate there, well, due to the number of parts. After that, everything was naturally put on hold. We checked it on the control surface, and everything was fine there. So, these kinds of elements, aluminium ones, which are made from bent pieces, so to speak, and riveted together, everything is moving forward. Everything is great. Soon we'll actually see the nacelle of the airship itself starting to take shape. We'll send ourselves there, and Gina and Vladimir, the cameraman. We'll be digitizing the whole process. After New Year, we also went to visit our future contractors, the manufacturers, to see the composite products. If before, it was basically just me going to the production site, now we went with a big team of designers, Vadim Vasiljevic, Vitaly, Dmitry Sergeyevich, Maxim, and Dima. Basically, the whole crowd went. We discussed the production process. Our composite products are as follows. These are not all of them, but the main ones. These are the propellers for the tail thruster of the Nova 2 airship. There, it's a two-bladed propeller. And there's a shifting mechanism to change the thrust direction, either this way or that way, so the tail can turn. These propellers themselves are composite. The development is entirely ours, the propeller itself, its profile, and this shifting device. The vector-changing mechanism, and the entire composite layup itself has been developed, what materials to use, how to lay them up, and so on and so forth. But the actual technological manufacturing process, and the manufacturing itself, we outsource to the company we've made an agreement with. So, this propeller is two-bladed. 2 of these blades need to be made for one airship. That is, we'll be making a set of 6 blades. That's 1. 2. We need to make, according to this mechanism, Maxim went there, had discussions. 2. That's the spring for the Nova 2 airship. It has a gondola, and under the gondola there's the front landing gear strut, which is spring-loaded. There are 2 wheels at the front, and this spring is also composite, but in general, its developer is DEMA. DEMA also went there. They discussed the details and nuances, and after that discussion we changed some things, and they understood some things in their own process, and so on. So, the spring is composite. Then, the ring propulsor propeller, the ring itself, the propeller, and the beam it's mounted on, plus some small elements. These will all be composite, plus the rear cowl, which will completely cover the engine compartment, will also be composite. And the lower part of the gondola at the front, there's glazing there, it's a single curvature, so it's straightforward to make. But the lower part of the transition from the gondola's bottom to the glazing, that's double curvature, so obviously that part will be composite, and this small skirt will be manufactured as well. So, the process has started, and soon we'll see the propellers, the small thruster units, everything begins with that. On our side, the test stand is being prepared, and it's almost finished. The stand itself has gone through several iterations. It will be a test stand for the 48-volt line. And in fact, 48 volts is one of the things they'll be powering, including the 48-volt tail thruster. The 48-volt generator will be mounted on this engine, on our main one, the Belgian one. The engine will be housed in a nacelle, and the tail thruster will be at the back. For now, the setup is such that the generator and battery are placed together, and a SIP cable runs from the battery to the back. There's a bit of a generational debate about this cable. The younger generation is against it, while the older one insists it'll work just fine. Anyway, the 48-volt test stand will be used to test this line, specifically the voltage drop over such a long distance. The voltage at the generator is just about sufficient, though not quite perfect, for everything to function. So, this stand is being assembled. It will have the generator spinning at the required RPM, all these long cables, and the engine. At first, instead of the engine or the actual load, electric heating elements of the necessary power will be installed. These will be switched around in different ways. Later, these heating elements will be replaced by the engine with the propellers. These propellers are composite, and the thrusters will be the first components to be manufactured. Here they are, along with the spring. The spring will take a bit longer, the propellers will arrive a bit sooner. The blade pitch adjustment mechanism is also now being sent for production and will be made soon. We'll then assemble the entire rear, stern unit. And we'll connect all of this to the 48-volt test stand, and we'll be testing the propeller as well. Among other things, so work on creating this test stand is underway. The generators were already purchased last year. These are the actual generators that will be installed on the airship. We bought them last year. There are, as it happens, Chinese generators and there are American ones. Their output power is basically the same, but their specific characteristics differ. The Chinese ones are heavier. That's one thing. And two, the American generator has a special control unit that squeezes out the maximum motor efficiency, so to speak, from the generator. The Chinese one doesn't have anything like that. It works directly. Well, in general, we'll test them both at the same time. But the Chinese ones are 10 times cheaper. So, we'll test both and see how they perform under different modes, in thermal conditions, and what kind of stability they reach. And also in terms of output voltage. Because usually, when it comes to components and procurement, it's always like, let's buy the Chinese ones. And that's it, but then you get Chinese volts or Chinese amps. Well, as usual, Chinese RPMs and so on. So, we'll test them. That's how things are moving in this direction.
That's all for the Nova 2.
That's actually just a small part of what concerns the Nova 2. If I start recalling everything now, one thing just leads to another like that. You asked what we do here in the office. We do a lot of interesting things. We moved on to developing design documentation and manufacturing electrical harnesses, cables, distribution devices, boxes, and all that sort of thing. We've already developed, basically, the entire structural and load-bearing scheme of the nacelle. I'd say about 95% of it is done. And now things are starting to be installed. Obviously, the engine is already mounted in this nacelle, the firewalls are in place, the fuel system, the ballast, which is also the caisson, the ballast tank has appeared right in the engine. The whole structural and load-bearing scheme of the engine compartment is sorted out. How the engine is mounted on its own frame, how the frame is joined to the nacelle. All the auxiliary equipment. The engine already has gearboxes, the actual swiveling transmission, the propeller, the ring thrusters. And now, basically, the installation of all the other instruments, the control system, and so on and so forth, is beginning. On this structural and load-bearing scheme, and along with it, since we're already determining the locations, there are already loads of electrical diagrams, both control and power circuits, all together. And since all this is in place, and the nacelle's geometry is set, we can already start designing the entire cabling system. Well, to be fair, it's already basically laid out in the diagrams. For example, this cable goes from here to there, it's of this cross-section, made of such and such material. But it still needs to be routed in the 3D model, its length clarified, and we need to figure out where it will be fixed. In general, dealing with the wiring harnesses is a whole separate story in itself. And all of this still has to be done to aviation standards, in line with all the norms and regulations. So, it's not that simple. These works only just started this year. Before that, there were only the diagrams. And now it's starting, for example, with Artyom in the lab. We all call it the lab, but in reality, it's the instrumentation department, strictly speaking. And the Department of Advanced Technologies, that's what we call it. We'll have a video coming out soon.
A brilliant video.
Yes, actually, during the course of last year, Tyoma was busy assembling a complex vacuum setup for various different stratospheric devices
For their testing.
to simulate the stratosphere. Basically, let's put it this way, for the most precise simulation of the stratosphere, down to the meter in altitude. Though measuring by the meter is a bit extreme. Like 100 meters, 50 meters, maybe, yes. Although, depending on the altitude, the composition and pressure change. And good simulation chambers are a very complicated and very expensive thing. Luckily, Artyom had almost all the equipment himself. Yes, because he's a science person anyway. Honestly, there's so much I'd like to tell about him. We'll do that at some point. His promise to start running this branch of content separately. But then there are the moves, and all that again. He was setting everything up, equipping the lab, then having to dismantle it all again, then re-equip it here. All in all, it was, as they say, a blow to the heart. So, there will be a video. Basically, we could have quickly assembled this setup. But we tested everything we needed to in it. And Tyoma said, I want to assemble it on video, because it's a historic moment. And we created a painstaking video of its assembly. So, it will be released soon. And what I wanted to say is, here's the kind of work that's being done. We were designing a production area. This is exactly about instrument engineering. Why do we even need it? Because, well, the airship is, in itself, a unique device. And it has its own control system. We have developed our own flight controllers from scratch. We have developed microcontrollers that are managed by the flight controller. They, in turn, control the actuators. And we need to manufacture our own microchips, our own circuit boards, our own instruments. So, we've put together a list of the minimum equipment needed so that we can calmly make our own instruments, devices, and so on right here. schematics, circuit boards, and the rest. And now we've started purchasing all of this. There will also be some cool videos, which we'll post later on. Our own converters, of course, step up, step down, DC to DC converters. Everything that's available on the market doesn't meet the stated quality. Everything we've bought, everything that's installed in the aeroplane and in Nova 01. For example, the main battery there is 72 volts. But the actuators are all different. Some need 12 volts, some need 24. You can't just buy batteries for all of them. So, of course, we use step-down converters everywhere. And all the step-down converters on the market, they all burned out. No matter how fancy they were, we had to patch every single one. We'd modify them, desolder something, solder in our own components, and so on. Naturally, you could get away with that on small devices, but on the big ones, like Nova 2 and those that come after, all such devices need to be designed in-house. But in order to ensure quality, reliability, and so on, we need to design all of this ourselves, and we already have. Now we just need to produce it in small pilot batches. So, we've set up a small area within the lab for this purpose. We'll be launching all of this very soon, and we'll show and explain everything. It'll all look great as well. Quite a lot is being done at the moment, but some things still aren't quite where they need to be. This all relates directly to the shell, specifically to shell production, and basically to these particular facilities. And because of the current funding situation, we simply can't afford to just take a large, clean site. So we're looking much further afield, searching for something significantly cheaper, even if it's a bit dirtier. Honestly, it's a complete nightmare there. I don't even know how to properly convey it all to you. It's incredibly sad, deeply frustrating, and very annoying. But it seems we've finally found some potential options. And there's a real hope that in February we'll move into a certain space and finally start shell production.
We already have the foundation for this.
The machines are in place. The machines are in place, waiting. The technical processes are being written. The cutting patterns are ready. The people are standing by, yes, well, with the space, of course. But, you know, it's only been 2 working weeks this year, so it's good that we've found the space. I'm really keen to get started on making the shell. The material is there, the machines are there, the cutting patterns are ready, everything is ready. And just imagine, we could have already made the Nova 2 shell by now. And then we'd be making the nose reinforcement for the fins more actively, otherwise. The conversation would be completely different. The VGS system is already almost completely ready for this shell. These are the fans, the valves, and we have already tried out various different setups. The mechanical valves are already done. Now we are making the electromechanical ones. That is so it can be controlled in unmanned mode. All of this is controllable. The unmanned version can fly with mechanical valves. The only thing is you cannot do forced opening. On the Nova 2 airship, forced opening is done so the pilot can do it. But on the unmanned version, well, obviously, there is no one in the gondola to open the valves. They are there, but the system can see them, can monitor how they are working. That is what the pilots who have flown airships in Russia are used to. That is how it is supposed to be according to certain regulations, and so on. And there, all the valves are opened by cables. But in the unmanned version, obviously, no one's going to pull the cable, so the valve has to be electromechanical. It has to work, obviously, if the pressure rises, it opens mechanically by itself, then closes by itself. It is simple, reliable, cheap, and so on. But, for example, if there is some kind of emergency situation where you need to force these valves open and release the pressure, the pilot can see everything and open them manually. But for the unmanned version, there needs to be an actuator that will open everything. We have already designed these valves. Right now, we are making them here in the office as well. For now, 3D printers are more than enough for this purpose. Everything fits in terms of weight, loads, and everything else. Obviously, once the geometry of the valve and the fans is finalized, we can send them to the thermoplastic machine and stamp them out. But for now, this is enough for us. The shell. Yes. Hopefully, we'll start making it soon. But again, let me remind you, we've already purchased the material for both Nova 2 and the Nova 01 combat version, so to speak. There you go. And at first, we'll be making it simply to set up the equipment, and then we'll test some shell for things like seam tightness and so on, not a large one, because that's expensive. That's it. But why is cleanliness important in the room? It seems clean, everything looks fine. And then you start welding this shell, welding the seams, and the seams seem to pass the strength tests. And then the helium escapes. That's dust. There was dust. The dust settled there, and as one of the airship building masters says, if you don't believe in the superfluidity of helium, when it comes to the cleanliness of the room, there are always some issues. Right? But it really does leak. And maybe, on a small section, say a meter of that seam, you might not even notice it much. But when there are loads of these seams all over the shell, then it becomes noticeable. And helium isn't cheap. If it's on Nova 01, it's still manageable, but on Nova 2, it's already a serious volume, a significant area, and of course, such mistakes simply can't be allowed at all. We hope to resolve this issue soon and get started on the shells. The engines are on their way to us. For Nova 2, as soon as the 2 engines arrive, the test stand is already being prepared for them. First, the engines themselves are started up, then the equipment begins to be mounted on them, and then it all starts to be integrated with the 48-volt line, because at first, an asynchronous motor on the stand drives the generator, and then, of course, we remount the generators onto the engine. Gradually, step by step, all this leads to the point where we leave the EVA here, and we have a device ready to be placed in the gondola. Well, obviously, after ground tests, of course.
There were questions in the chat regarding Dubai. It was mentioned that there are contacts, some work is being done, communication, interactions, maybe some.
It's ongoing, and after the new year, all the work has resumed and is progressing. Well, the most significant thing, the one that's really close, is that we've already sent a commercial proposal. It was approved, and now, together with the client, we're working out the financial model of his business for the use of these products he needs. It seems everything is coming together, and we've set a deadline with him to get this done by the end of January, and then there will be an order.
Which machine is he interested in?
I can't say just yet. Let them sign, send the advance payment, and then I'll tell you everything. They need several, yes. All right, they're easygoing. Let's start with that.
That's already good.
Yes, rigid airships are completely out of the question straight away. Obviously, no, they are definitely soft. Right, let's just leave it at that for now. That's probably the closest thing we have for the time being. And to be fair, they're not exactly small either, I'll say that as well. That's roughly about their current price point.
In fact, this is one of those rare cases where we've actually received an order for something we don't even have yet. Well, within the company AERONOVA, we haven't built such machines so far.
You've just given another hint. Well, in general, there are a lot of contacts. I've said this before. And with each of them, we work through exactly what they need. We don't have some specific offer, like, here's a ready-made iPhone, just come and buy it. No. Everyone has their own tasks, their own particularities of use, their own specifics of the area where it will be used, their own requirements for various, well, loads and so on and so on. And, roughly speaking, together with the client, you create the concept of this machine. And you don't just create the concept as an artist, like, I'll just draw it now, you have to calculate it as well. Everything has to be justified, and so on and so forth. And all this takes time, and there are several of them, while there are few of us. So, basically, when people ask the question, I answer, we're working. And we're working as efficiently as possible, as much as is realistically possible. To meet all the requests, we're constantly in touch with foreign clients. Through interpreters, too, we communicate, clarify things, whether it's about airships, stratospheric airships, or stratospheric probes. The work is ongoing. Which of these will bring in money and when, we'll see. I've already told you the shortest version. By the end of January, which is just a day or two away, we need to finalize this model, and then in February, most likely, some decision will be made. That would be fantastic, of course. I'd be over the moon.
Not just you, I reckon. Do we have any events coming up soon? Maybe some trips or something else?
Yes, both events and trips. There's a lot planned. Speaking of events, just to digress a bit, right now the royal readings are taking place in our country. Those in the know will understand what that is. Well, Dmitry, we at AERONOVA received an official letter, an invitation to take part in the royal readings. And Dmitry Sergeyevich Khmel will be giving a talk about various inflatable structures that can be used in space, for example, for lunar exploration, as well as for different types of orbital inhabited stations, and even for exploring Venus. Venus has a dense atmosphere, and at certain altitudes it's not. Well, in general, there are many projects. If you haven't looked into it, do check out the fact that in the upper layers of Venus's atmosphere, it's possible to be present there using airships on such aerostatically supported platforms. Back in Soviet times, probes of this airship type were already used to explore Venus. Well, not exactly airships, but simply aerostatically supported probes. And Dmitry Sergeyevich is our scientist who specializes specifically in this field, in Venusian research. So, yes, right now the Korolev readings are taking place. Dmitry Sergeyevich will be presenting there. And we have set up our shell production with the idea that we can manufacture all sorts of structures of this kind, not just for our own planet. We know the upcoming programs and what will be in demand there, and we're happy to take part in all of this. Certain work is already underway in this direction. I won't talk about that just yet. About the events, this is just one of the upcoming ones. It's actually happening this Saturday. Well, to be precise, the Korolev readings are already underway. Dmitry Sergeyevich will be speaking there on Saturday. We'll go have a look. Maybe we'll even show you something from there.
And in our department, can microturbines be considered a promising technology?
Well, microturbines are, after all, power units, so it's the power units department. As for news, basically, what's happened since the new year? Our esteemed Chinese colleagues have sent us reports on the completion of bench tests for the electrical part of our microturbine. We ordered the generator from them. It was practically a development project. They were designing an electrical generator for their own turbine, but our frequencies, power outputs, and so on are a bit different. So, they reworked it for us. In general, they re-engineered it together with us. We helped them with the calculations. They definitely manufactured it, and now they've completed the bench tests. It operates in two modes. It works as a starter and as a generator. So, they've sent us the full reports now, including photo and video documentation, as well as the main report with all the graphs, measurements, and so on. And now our specialists are studying this report. If you just glance through it, everything is excellent, just as it should be, everything worked out. So now, after we accept these reports, they will prepare the final technical documentation, detailed instructions, and so on, and all of this is moving in our direction. So, congratulations to all of us. We will have a generator with 300 kilowatts of electric power. I'll tell you about its technical specifications a bit later, but it's a very compact, lightweight device. In general, for those who don't quite understand, I can explain a bit more. For example, an electric generator with a capacity of 300 kilowatts. Some might say, why invent it? Just go and buy one. Well, we could go and buy one, but firstly, it's quite expensive, and secondly, it would weigh so much that the whole airship wouldn't be able to carry it, because it operates at low revolutions. Basically, if you increase the revolutions, you can reduce the size of the generator. Those who understand, I don't need to explain to you. For those who don't, just listen. Our generator operates at 45,000 revolutions per minute. That's the speed our turbine runs at, and it connects directly to the generator without any gearboxes or anything else. So, our 300 kilowatt generator is a rather small, compact device, and it's already been obtained an electric generator. There you have it. As for the microturbine, the faster it spins, the more compact it becomes, and it starts to be suitable for aviation. That's exactly the kind of microturbine we designed for aviation, to provide a stable 300 kilowatts of electric power with high resource, a long service interval, and so on, and so on, and so on. All of this has been achieved, basically. The generators are ready, the inverters are ready, and soon they'll be on their way to us. And what about the turbine itself? Designing a turbine is, of course, a colossal effort, and manufacturing it is no less of a feat. Those who know the field can say a lot of interesting things, like, well, we haven't been able to do this in our country for many years, even decades, and so on and so forth. Yes, it's a fact that the product is complex, but when we designed it, well, there are certain critical components where we used old Soviet parts, ones that are 100% reliable. For the parts we will manufacture ourselves, we sacrificed many of the turbine's characteristics for the sake of ensuring it could actually be produced and would definitely work. But that doesn't change the fact that these are extremely complex products. We'll be manufacturing some parts ourselves, but most of the components for the first turbines will be made at facilities we've already been working with, and we've come to an agreement with them. For example, the compressor wheel, it's clear who will be making it. It's made of titanium, and it will be milled. This titanium compressor wheel is 300 millimeters in diameter, about this thick, and it'll be machined from a solid piece, which is quite a task in itself, but nothing too complicated. After that, it needs to be balanced for these rotational speeds, and that's where things get a bit more interesting. So, regarding the titanium cold wheel, it is already perfectly clear exactly which team will be responsible for manufacturing that component. As for the hot compressor wheel, this will be cast either from the heat-resistant GS6U alloy or alternatively from Inconel and then ground down. Again, we are already well aware of which specialist firm will be taking care of that particular stage. The shafts, specifically the compressor shaft and the rotor shaft, it has already been decided precisely who is going to be tasked with producing those specific parts. In general, every single one of these individual tasks is going to be managed and executed by a variety of different people. Then the heat exchanger, we know who will be making that as well. All the other small bits, it's clear who will be handling those, and the housing components too, it's obvious who will be responsible for those. Roughly speaking, if we count it up, I haven't yet estimated exactly how many subcontractors there will be, but it wasn't easy to find them. There were endless refusals, because the precision required is high, and the alloy too. Plus, since these are one-off items and not a series, and most companies that manufacture such serious components are set up for serial production, for them to just switch over for a single item is either too expensive, or they simply don't want to do it. First of all, everyone is amazed. Wow, our respect. Yes, we can see a lot of serious work has been done. It's astonishing that anyone is even making this at such a quality. But we can't do it. We'd have to stop the whole factory, and that's not allowed. But we found everyone. It's all fine. Now it's just a matter of paying and waiting. Well, not just waiting passively, of course. We're actively waiting. We're preparing the assembly production for this. We've already started selecting specialists. We've already chosen them. We just haven't officially hired them yet, and so on. The requirements for the assembly and testing section are fully formed, and so on. We're starting on these technical processes, methodologies, and so forth. Let me remind you again, for those listening and thinking, wait, is this a dirigible project or a microturbine one? Let me remind you where microturbines came from and why. There are no aviation engines for dirigibles. Does anyone make them? No. In Russia or in general? Both in Russia and in general, really, aviation engines. You know, it's like this. Can you use some sort of aircraft engine, say, one that's already available on the planet? You could answer, you can or you can't, but why would you? Of course you can, but will it be optimal? It won't. Will we be able to build the airship of the future? Absolutely, and in any case, solar panels will be added there. You can burn hydrogen, for example. It's actually a green fuel, and turbines are capable of running on it. So, turbines are the best option out of all of these, and we're lucky to have a huge team led by Andrei Veniaminovich, who have been working exclusively with these turbines all this time and are now gladly helping us. In short, for the large airships of the future, microturbines are absolutely essential. If we use a Belgian helicopter aviation engine on the Nova 2, we can't use it on the Nova 8, nor can we use any other engines. What we can do, it would be great if by then we already have a microturbine developed, tested and produced. 2 microturbines for installation on the Nova 8 airship. Then we can use electric motors on board to spin the propellers, and everything will be cool, great, and fantastic. But if that doesn't happen in time, there is an option for how to fly the Nova 8 without microturbines. There is a concept in light aviation called autoconversion. For example, at car factories, they take Toyota or Subaru engines and so on, modify them a bit, and you can, in theory, install them on an aeroplane or even an airship. It is possible. They would need to be slightly modified to become rotatable, and the oil system would have to be changed. But it is possible for such an airship to fly. Yes, it is possible. But can it be certified? No, it cannot. So, does that mean the Nova 8 will fly without microturbines? It will fly, but most likely not as a commercial product. There were some other aviation rotatable engines, I think, but they've been discontinued. I can't remember what they are called, but those who know will understand perfectly well. The turbine has reached the production stage, and its next modification is already being developed. As I said, we specifically incorporated solutions into this turbine to ensure it would definitely be produced, would definitely work, and would definitely operate reliably. For example, it has air bearings, they are oil-free, and so on. There are a number of solutions we're planning for the next turbine, where 70% of the parts will remain the same, like the recuperator, the casing, and so on, but 30% will be improved. The turbine will become lighter, more compact, much more efficient, and so on. However, the production process for that will take a bit longer. That's the current situation with the turbine, if we're giving an update. I'll share a bit more about them in a moment, but I want to remind you that a microturbine like this is already an incredibly cool product, which can easily be commercialized, and for which we already have separate investors. These are people who worked with Andrei Veniaminovich in a previous life, and they're interested, in general, in setting up a separate enterprise for microturbine production. The investors are keen, but our own intentions haven't quite crystallized in that direction yet. In general, negotiations are underway about their willingness to invest in building an actual factory in our country to produce microturbines with ratings of 300 kilowatts and 400 kilowatts and 50. Yes, it's a very interesting project. This microturbine has a capacity of 50 kilowatts. It's absolutely tiny.
Are they interested in this product as some sort of energy generator?
3 to 400 kilowatts is industrial-scale electricity generation. It's distributed energy. It's a massive market, an absolutely enormous and promising market. The best part is, we are capable of mastering it. Yes, you see, everything was thought out in advance. And small turbines are interesting as range extenders for electric vehicles. These so-called range extenders are used in hybrid cars, where something burns fuel, but the drive is still electric. There's a battery, but it's more of a buffer, so to speak. It's not designed for the entire journey. It discharges along the way. And this something charges it along the way. This something could be a piston engine, for example, but an internal combustion engine, ICE, microturbine, is also an internal combustion engine, only it's of the turbine type. And these small ceramic microturbines of 50 kilowatts are needed in the millions, really, and factories producing 1,000s of them per month are in high demand. Many people are interested in them, both in our country and abroad, and we need them too, for aviation, for airships. They're just a really cool product. In general, we'll talk about them separately and show them. Last year, we kept this under wraps and didn't talk about it, but of course. Well, I wouldn't have had time to tell about everything anyway, to be honest. You mentioned the trip. Some of the co-contractors involved in manufacturing this turbine are Chinese companies, the same ones who make generators. They designed and produced their own generator for their own turbine, as I mentioned earlier. But when we ordered a generator from them, just as a generator, we didn't tell them it was for a turbine. However, during the refinement process, they told their turbine specialists that they had Russian turbine engineers, and we got acquainted with them. We asked about their capabilities in manufacturing a compressor wheel, for example. They received the 3D models, confirmed that production was possible, and actually became interested not just in manufacturing, but almost in setting up a joint venture in China for producing these microturbines and so on. So, most likely, I'll be flying there soon, specifically regarding its production and to discuss these joint ventures. We've received a number of, well, you could say, honestly, this is explosive news. I don't know why I'm saying it so calmly. I'm nervous and not sure if I should be sharing this. Anyway, we've had a lot of proposals from the Chinese side about setting up joint ventures, where we act as the developer and they act as the investor and manufacturer in China. But with different terms. Some have one set of conditions, others have another, and a third group has their own. Some want to use our turbines to cover the Chinese market, for example, and leave the international market to us. The shares and arrangements vary. We've managed to coordinate everyone for certain dates, and I'll go and negotiate with all of them. We'll agree on some preliminary, more or less firm agreements, and then we'll think about how to move forward with these joint projects. As for production, I'll go there myself, we'll finalize everything, I'll visit the factories. I'll film there, or maybe I won't, we'll see. Because the company, there is also a serious aerospace enterprise. Maybe they'll even take my phone at the entrance, but then you'll just have to take my word for it. What can you do? We'll see. So, this trip is also planned for the very near future, really soon. There's a lot going on with the microturbines as well, and honestly, there's something happening with almost every part of the airship. We just don't have time to tell you about it all. We haven't even managed, in all the time that's passed, to organize the release of juicy, dense, information-rich content. There's just so much going on. We simply don't have time to package it all and share it. So, it ends up that we can only tell you about it like this, in webinars, and wait for, well, what are we waiting for, really? Jen, what's going on? Where are the videos?
A lot is happening. One of the juiciest videos will be released literally tomorrow, on Friday, closer to the evening, straight from the laboratory. So make sure to be active there. The video is high quality and really cool.
But this was Artem's personal wish. He wanted to immortalize, so to speak, the assembly of this vacuum device himself, because it is truly unique. Even within our country, you could probably count such devices on the fingers of one hand, and if you managed to bend all the fingers on one hand, that would be surprising. But as for microturbines, we'll need to start a separate thread about them.
We've already started. We've written a big article, introduced Andrei Veniaminovich, and perhaps, sometime in the near future, we'll invite him for an introduction.
Yes, I suggest we do the next podcast with him. At the same time, we'll prepare and get a presentation on microturbines ready. We also wanted to invite Dmitry Sergeyevich. Let's start with Andrei Veniaminovich first. Basically, we'll introduce what microturbines are in general, who else in the world makes them, where they are used, what their markets are, what we've designed, what its potential is, what markets it has, and what we plan to design next. We'll talk about Andrei Veniaminovich separately. This can either be done as part of a video, create a good informational video, and then let's collectively assign Gennady the task of making a big separate video about microturbines, then hold a webinar with the Andreis, a get-to-know-you webinar, and after the introductory webinar, release a video, for example, like that.
Excellent. Well, it seems those were the main events that have happened over the past half-month of work. I suggest we smoothly move on to the questions.
That's probably not everything, but yes.
We've already spent a lot of time talking, and I think we have plenty of questions there. First of all, people are asking for an office tour. They are curious about how everything is set up. We promised it, but still haven't done it yet, I admit. In the coming days, I'll get right on it. The main question being asked is whether the project will be able to develop actively without Russian investors, and if everything will be all right. It's a relevant and pressing question. In any case, the project will continue to develop. As far as I know, Russian investments made up literally about 20, well, not literally, but a significant 20 or 30% of the market. Solar Group will definitely hold a webinar soon to explain all the details and nuances about the future work that's planned, and will answer all the current questions. If you have any urgent questions, our technical support is working actively. You can write there, and we will definitely answer all questions. No Russian investors are being abandoned or left behind. All the conditions that were agreed upon initially remain in place, but we have to work with what we have. So we must comply with the laws and regulations of the Russian Federation. We'll have to adapt. There's no other way, as I said. I can't give exact dates yet. Solar Group is preparing to gather all the necessary information, and as soon as they are ready, they'll definitely hold a webinar with a complete information base and steps on how we'll move forward. So, we'll be in touch soon. Please comment on the situation regarding the closure of investments from Russia. I've commented on it.
Next question, please comment. Honestly, it's very painful and sad. Everyone is in shock, and even before this, money was barely enough. Even here, a lot has been done, optimizations and so on, and with this premises, with the shell company, it's not just dragging on for no reason, it all comes down to money, and now this as well. It was a sad time. Some people even started to panic. A deep bow to our foreign partners and investors. They really pulled us through January. Apparently, they were also scared that something might go wrong with the project, and usually, statistically, January is a tough month after the holidays, as people have spent money on gifts. But this January, all the statistics were turned upside down. Thanks to the foreigners. The webinar is mainly watched by Russians. We've got India, Africa, Vietnam, all very active countries, and things are working well there. Let's hope the foreigners will continue to develop all this, and that Solar Group will come up with a proper mechanism from the Russian side.
Actually, as far as I know, work on this issue started long before all these events. but they just didn't quite manage to fully enter the legal zone in time, though work is ongoing. By the way, it's not only our foreign partners who can work. Russian partners can also continue their partnership activities, but only on architectural urban solution restricted platforms. It's absolutely not recommended to do this on Russian platforms. It's not recommended to do this, but there are other platforms, well, you know which ones, the ones that are not allowed in Russia. What are you going to do with the boathouse, build or rent?
Last year, we met the owner of a private airfield, with whom we negotiated both renting and building on his land, and the agreements were made. They didn't go anywhere after the new year. We got to the point where we were given the master plan, and on that plan we placed the boathouse, mooring points, taxiways, and so on. In general, we mapped out the whole scheme. So, we said, let's get started, but then the frosts began, so we decided we'd wait for the snow to melt and then begin. Everything remains in the plans. Roughly speaking, for now, there's clarity regarding the land, the airfield, and the boathouse, and we're in contact with the manufacturers of the boathouse itself. What are we waiting for? Just for the snow to melt so we can get started. There, too, we'll need to pay a fairly large sum in one go, and this amount is much bigger. Someone said, money was set aside for the airfield, the money wasn't spent, everything's great. In general, the airfield cost 20 million rubles, which, for an airfield, you could say is nothing. If you've looked at the ads for agricultural airfields, you could buy one for 5 million rubles, or 6 or 7. That's just an airfield on paper, but in reality, it's a cornfield where there isn't even an electricity pole nearby. But that's not really the point. Here, there are airfields being sold for hundreds of millions of rubles, and of course, we didn't have that kind of money. Last year, we didn't even consider buying one like that, although we did go and have a look. There, you've already got the airfield itself, a runway, some hangars, even a hotel, repair workshops, and so on. We're talking 200 million, 300 million. There are airfields for 400, 500 million and upwards. But the one we looked at was an agricultural airfield, though it had already been improved. There was already a hangar big enough to fit the Nova 01 and, say, the aeroplane. All that needed doing was to redo the gates. There was already a little house where you could stay overnight, electricity, water, and so on. The price was 20 million rubles. We were planning to buy it, but in the end, they didn't sell it to us because they decided to keep it for themselves, and they also had issues with the paperwork. Since we were trying to do the deal through a notary, the notaries were going through the documents, and it turned out that one thing, then another, then a third needed to be redone. So they thought, oh well, never mind. At that point, a couple more planes arrived at their hangar for rental. Basically, their monthly income went up and they thought, actually, it's not bad, let's not sell. So that's what happened. At the time, we were also planning to put up an inflatable frame hangar for the Nova 2 there. And what I want to say is, someone said we didn't spend the money, that we still have it, in fact. If you add up the cost of the airfield and the cost of the inflatable frame hangar for the Nova 2, it would be less than half the cost of an inflatable frame hangar for the Nova 8. So, the decision was made to go straight for the inflatable frame hangar for the Nova 8. Firstly, because we'd already delayed with the inflatable frame hangar for the Nova 2 in general. There's no point in spending a lot of money just to then spend even more money later. It's easier to skip the first step altogether. And with the owner of this current airfield, we agreed specifically on a large hangar, and already for the bigger airships, he's got enough space to accommodate both the Nova 2 and the Nova 8. So that's how it is. As for the location, where is it now? It's quite far, but for now I don't really see any point in going there. I'll go and we'll shoot a video from there when we start pouring the foundation slab for the inflatable frame hangar, and that's when I'll tell you everything.
Right. I'll move on to the next question then. Maybe each engine could have its own control system powered via fiber optics. That's probably in the context of our discussions about electric motors.
Everything will be controlled via fiber optics anyway. Each engine will have its own small turbine, so in the end, that's probably how it'll all turn out.
Is there a plan to build a larger Airship this year or next year?
This year, we'd like to see not only the Nova 01 appear as a product, not just as a flying laboratory, a dynamic replica, and an Airship, but also the Nova 2. Yes, it's planned. Once we complete the dynamic high-speed tests of the aeroplane, we'll see how well the aerodynamic theory matches up with reality. If nothing needs fixing, we won't change anything. If the body needs adjustment, we'll sort it out. And yes, we'll start, but this time we'll produce not a laboratory prototype, but a full-fledged product, a small hybrid airship. But with the same volume. More or less. There are certain considerations regarding the volume of Nova 01 where it needs to be moved, and similar considerations will arise for the aeroplane. As for Nova 01, it's currently about 130 cubic meters, but we're now looking at between 200 and 300 cubic meters. I won't specify the exact figures just yet, but we're considering between 200 and 300 cubic meters. We'll have a classic-shaped airship, but now as a product with product features, meaning it could be handed over to someone for operation, not just managed by the people who created it, making it safer, more reliable, and so on. As for the size of the aeroplane, we'll decide once the tests are done, but they're too, more or less, everything will become clear. It's quite likely the aeroplane will remain the same size.
The question here was specifically whether an increase is planned.
Are we planning to release a new, larger one? In reality, due to saving resources, we are currently focused only on the new 2. Everything else is being done with a minimum of resources and minimal attention. If at some point our resource shortage comes to an end, naturally, we will start working more broadly across the range. As for hybrid airships, there is active discussion about whether they are needed. We are sharply divided. Some believe the classic is enough, while others think hybrid craft are necessary. At the moment, of course, we are assembling and testing the aeroplane because theory is one thing, but practice is another. In practice, it will show itself somehow, and the theory will be backed up. And roughly speaking, the position of the hybrid supporters will either be strengthened or weakened. We shall just have to wait and see exactly how it all goes. Of course, there are certainly plans in place to build hybrid airships, if they can eventually manage to find their very own specific area of practical application, so to speak, because their niche either becomes more restricted or significantly expands in theory for now. In actual practice, we will just have to wait and see how it all turns out in the end. For Dmitry Sergeyevich, as the chief ideologist of Aerolet-type airships, this is his creation, his brainchild. Hybrid airships up to 40 tons make economic sense, are applicable, and so on. He doesn't consider anything above 40 tons for now, but even the classicists are trying to reduce that 40 tons as well. There is a problem going forward, and it's related to the hull design. The aerodynamic hull is not the right shape, meaning it's not circular in cross-section, but rather a tricky shape. And any soft structure, when you apply pressure, tries to take on a circular cross-section. So, to create non-circular shapes, you end up making the envelope heavier, so to speak, by creating internal membranes. On the one hand, it means you seem to be making a small hybrid craft, but it ends up making itself heavier, so you can't really use it efficiently when it's flying. In short, building a large rigid one straight away, there's neither the money, nor the time, nor the desire for that. And what the next hybrid craft will be, and what size, is hard to say for now. There are certain developments we're moving towards. These are semi-rigid, pneumatically framed hulls. There is a solution, for example, to make a hybrid airship of exactly the same shape as the AERONOVA type, of the Nova 2 size, but it will be able to lift, for example. If the Nova 2 lifts 500 kilograms, this one will be able to lift 2 tons. That is, of course, a significant difference. Whether we will build it or not, we don't decide just like that, whether we will or won't. We have clear regulations, a scientific and technical council where all these decisions are made. At the very least, from a scientific and technical point of view, we have to justify whether this project is even feasible. But then, as I said, the financial aspect comes into play as well. So, for now, it's all within the framework of something like Nova 2. I think, overall, that answers the question.
Let's move on, then. Here, they are saying that an electromagnetic shell is needed, one that would repel helium. A powerful electromagnetic capsule. Do we know anything about this?
Actually, there are various scientific studies where researchers try to charge helium electrostatically in an attempt to somehow contain or even repel it. It's certainly not our top priority at the moment. Perhaps it's noted somewhere in the archives. There are several clever tricks for how this could potentially be done, but it's really not that simple at all. You also require a very high level of specialized expertise in some incredibly advanced technologies. For example, one would need to focus on creating pulsed nanosecond generators that can produce megawatt levels of power. Then, hypothetically speaking, something might actually work, and one day we will eventually get there.
Good evening. Will you be releasing the Nova 8 next year, or later?
If we manage to get the shell production sorted and set up this year, then we'll start making the Nova 8 shell this year. When I say start making, I don't mean we'll have it fully ready, but at the very least, we'll get it welded. Right now, we're at the stage of ordering materials for the Nova 8 shell, because it's not like the one for the Nova 2, it's tougher, with stricter requirements. If, for example, we order it at the start of this year, it should arrive around midsummer or autumn, which means we can start manufacturing then. That means everything else will gradually fall into place, and next year we should see the Nova 8.
That will already be 2027. So, the next question, if we manage to set up serial production of microturbines as a separate line, will it bring profit to AERONOVA, and accordingly, dividends from them?
We haven't discussed this directly yet. Whether it's a definite yes or a definite no, but if this develops within AERONOVA, then logically, yes. If you launch it all as a separate story, as a separate business, it's such a big branch with its own completely complex work. For example, within the framework of creating the airship line, to design a turbine for yourself, have it made somewhere, and then ask someone to produce it, that's one thing. But developing a separate business, setting up serial production, is something else entirely. There were even ideas to launch microturbines as a separate project with their own funding, but for now, that's not possible. And since it developed within AERONOVA in its first year, of course, AERONOVA will get something in the event that the microturbines are spun off. If they do separate, then naturally everything goes to AERONOVA, which means to the new investors, of course.
Right, it seems like I've run out of questions. I can just quickly check once more.
To give you a general idea, there is currently a small team on payroll working on the airship construction project. Building a factory for the serial production of microturbines costs 3 billion rubles. So, roughly speaking, if you take all the money people have invested in AERONOVA so far, then subtract only what has been spent on microturbines, and then divide that by 3 billion, the resulting share in this serial production would, of course, be very notional.
So, are there any more questions right now? What motor efficiency is expected from the microturbine for the airship?
It's about the same as the most efficient diesel engines. For the exact figure, you should ask Andrei Veniaminovich so he can provide it. I saw a lot of comments when we talked about the turbine. People said, oh, its efficiency is low, it consumes a lot of fuel. But that's not the case with a recuperator that returns 95% of the heat back. It starts to work a bit differently then. Their efficiency and fuel economy get close to, and at some point even surpass, diesel piston engines. In reality, the competition is already down to fractions of a percent, 0.5%. So I won't name an exact figure. Andrei Veniaminovich will explain the theoretical numbers we can expect, both for the upcoming developments and for those further down the line, the promising ones, and he can also talk about the theoretical limits. So we'll make a good, high-quality review.
We'll do everything. Is there any plan to build airships as a form of international transport, similar to trains or aeroplanes?
If there's a client, of course, we'll do anything. For now, the only international use we see is as a cruise liner, because every country's landscape is beautiful, vast, unique, and rich. You can't really see much from a plane or a helicopter, and sailing across the ocean, sea, or river is different, but with an airship, it seems you could. Still, international air travel by aeroplane is already so well established and luxurious that there's really no point in trying to enter that market. Whether for transporting people or cargo, an airship simply can't compete, ever. If you need to move something large and heavy, or, conversely, something big but light, and there's some economic sense in it, then, of course, such transport flows will start to form over time. For example, between China, Europe, and America, the very Silk Road, so to speak, where the infrastructure exists and there are developments underway. We spoke earlier this year with a transport company that has a huge cargo flow, and they themselves concluded that they'd use airships for things that aren't profitable to move by train, plane, or anything else. If there were an airship, it would be wonderful. And surely such cargoes and cargo flows will be found, and eventually, everything will fall into place. But you see, this won't happen at the very beginning of the industry's development, when everyone's fighting for every penny of profit. For now, I hope the focus will be on filling those niches where there's no competition at all. That's where it's profitable, where you can earn well, and therefore continue to develop. There's no point in competing where competition is fierce, especially when you have a whole vast market available. International air travel is still far too competitive a market, but there is room to move in other directions.
With airships, you can really go far. Now, someone here is commenting that the AERONOVA blends in with the cloudy sky. Perhaps you could paint bright patterns, or a vibrant livery on the sides.
We could, just not on this one. I think I explained before why they're this color at all. It's because the fabric contains a component that prevents ultraviolet from destroying it, which is why it looks like this. Of course, we do plan to create designs and paint various things on them in different colors and materials, but all of that costs money and time, from developing the design to actually producing it. For now, there's really no point in spending on that. I agree, it does blend into the sky, stealth mode.
By the way, someone here is asking, does the sad fate of the Airlander hybrid airship project not bother you?
Not in the slightest. They went down a path, thanks to them for that we won't be taking. They've contributed a lot of experience to the global airship industry, and now, by learning from their experience, we can do things properly.
There's also a question about why there are no orders for the hybrid. It's odd, your right hand doesn't know what the left is doing. I didn't quite get the question. Why are there no orders for the hybrid? And at the same time, it's strange. Your right hand doesn't know what the left is doing. So, basically, why are there no orders for the hybrid?
There are preliminary orders for the hybrid. For example, within the country, there was an order for 3 tons, 30 and 60 tons. They specifically stated that the airship should be a hybrid, but they are acting as an expert customer, meaning they understand what they are ordering. They say, we need ballast-free loading and unloading, meaning the airship should arrive, drop off 3 tons and fly away. And for that, it needs to be a hybrid. We have nothing to ballast it with, and there will not be a return load. So, there is a customer, but the question is whether we can solve this task with a classic-shaped airship. Why not? Can we solve it with a hybrid? Yes, we can. And has the customer paid any money? No. We're still at the project stage. This does not happen quickly. As I mentioned, the technical designs are being developed, and the mathematics is being worked out. The requests are not just, I need a hybrid for 3 tons. Everything has to be calculated, including technical maintenance, ground storage, repairs, the crew, and absolutely everything. Major clients do not hand over large sums of money just like that. Entire scientific dissertations are created beforehand. Of course, some are willing to pay for the creation of a scientific dissertation, while others say, no, create it and demonstrate your expertise on your own. There are both types.
So, another question. Will you somehow respond to the regions, or will you go to the Chinese? I've rephrased the question a bit. There's a client we've been talking to for over a year, but there's been zero response, even though they're ready to finance. Will you somehow respond to the regions, or will you end up going to the Chinese?
I didn't understand anything. What was that about again? I'm fairly certain he's reciting a quote, by the looks of it. Yes, he is. We'll see. Objectively, I'm just assessing the situation. Andrei Veniaminovich, throughout his rather long life, has interacted with Russian investors and clients. He's had projects, and successful ones at that. But there was also a range of experiences where, even in Russia, people appeared with whom agreements were made, even money was allocated, and everything was done properly, but along the way, the developer and the development would get lost. And in China, there were repeated, fruitless attempts over many years, so I don't know about any specific client. For some reason, I associated this with turbines, judging by the context. Right now,
We're doing things for ourselves and for our airships, but if somewhere, somehow, it works out to create a joint venture and someone wants to help us, we won't refuse, whether it's in our country or in China. Why not, really? In any other country as well, if the work of our scientists can be realized in metal, and we can use that metal ourselves,
put it on our airships, on planes, in cars, and if we can all earn from this together, then of course, yes. Well, I believe that is all the questions we have time for today. It has certainly been quite a long and productive session for everyone involved. To all our friends who are watching these webinars regularly, I want to say that it is absolutely great to have you with us. Thank you so very much for your thoughtful questions, your detailed answers, and for your continued interest in our work. I fully understand that many of you probably wanted to hear much more about the current situation regarding the Russians and that whole story. I truly hope that Solar Group will be able to provide a full answer to everything very soon indeed. Things are really buzzing here. Everything's moving and working. After seeing the aeroplane fly, honestly, a lot of people got inspired. Wow, the Nova 01 is flying. The airship people are watching. Just wait until you see the big one. They've seen it, of course. But even they were surprised when the aeroplane took off. And even though the video clips are short, they've spread everywhere. Plane enthusiasts watched. Helicopter people watched. Everyone got interested. Everyone perked up. The microphone's in an awkward spot. It's uncomfortable to sit under it. When the classic airship finally took off, people just thought, an airship, the classic sausage shape, it flew, it flies, it's cool. But when the aeroplane took off, with its rather odd shape and completely different way of flying, it sparked genuine interest. That really made us happy and inspired us. Many people from relevant companies are calling, wanting to come and see it for themselves. And by the way, some pretty cool guys from a big Russian corporation came to visit, young lads with their own specialization. They also work with unmanned technologies, but on the ground. They said, wow, what is this? Let's come up with something together. So, with just one short video of the aeroplane, we actually caused quite a stir in certain circles. And now, as soon as the weather clears up, we'll keep making noise. I want to go further, do more. We've got the little Nova models ready to fly. The classic aeroplanes will take off too. And when we get the Nova 2 up in the air, that's really going to be something serious. We've honestly made a splash in the world with just 2 little flying packages. Who knows what's next? In any case, everything's going to be great.
On that note, I suppose it's time to say goodbye. Friends, please do leave us comments and share your reactions. It really means a lot to us when you write something or respond in some way, because we're doing all this for you as well. Share the information sensibly. We're simply trying to popularize the topic, to show that airships are cool and exciting, so that more and more people find out that this field is making a comeback, that soon we'll be seeing airships above our heads, and so that more people will want to see them in our skies. We'll do our best to make sure that, here in Russia, they become a sort of flagship and set a standard that everyone will aspire to. Well, it's time to say goodbye.
Yes, that's all for now, friends. See you in the chats, on Telegram. Keep an eye out for our videos. When will we be back next time?
It'll be in February in any case, but probably closer to the end of the month. We're doing this every 2 weeks now, but in any case, there will definitely be an announcement. We'll let you know.
So, in 2 weeks it would be the 12th of February, but on the 12th of February, a group of foreign investors wants to visit the airfield to see the airships in flight. So, either we'll move the webinar to the next day, or postpone it by a week, not on the 12th, but a week later. Anyway, see you soon.
Yes, thank you all. Goodbye for now.
Solar Group presents. This was once just a dream of the skies, the freedom of flight, of round-the-world journeys. Yet we've made it happen. But what did it take? Our dreams became our goals. Our concepts turned into our plans. Our ideas have transformed into a roadmap and production technology. And the years ahead are booked out with development and construction, components and materials, model manufacturing and testing. All this marks the progress from dream to result. Join us on this journey. Solar Group presents a new generation of airships. The best way to predict the future is to create it, so let's do so together.